we would like to look at the proof of this Laplace transform. So it is the Laplace of the integral from 0 to t of f of tau d tau, and that is going to be equal to f of s over s, where I would ask you to recall that we're saying that the Laplace transform of f of t is equal to capital F of S. So that is the notation that, that we always come back to. And so the way that I will set up my proof of this one is to start by defining the function that we're taking the Laplace transform of as being g of t. So that is that g of t is equal to the integral from 0 to t of f of tau d tau. So this is a function that's defined in terms of an integral. And then what I'm going to do is take the derivative of both sides of this with respect to t. So the derivative with respect to t of g of t is going to be equal to the derivative with respect to t of the integral from 0 to up to t of f of tau d tau. So hopefully you recognize here on the right side that I am looking at one of the fundamental theorems of calculus. I'm taking the derivative of a function that is defined in terms of an integral. I also think it's worth pointing out up here that the way that I defined my function g of t, that g of 0 would be equal to 0, because then I would be integrating from 0 to 0. Okay, so now when I take the derivative of both sides of this, I will get on the left side, I will get g prime of t, and on the right side, I am going to get f of t. That is taking the derivative of the function that is defined in terms of the integral. That's straight from the fundamental theorem of calculus. And then what I'm going to do is take the derivative of both, take the Laplace transform of both sides of this. So the Laplace of g prime of t is going to be equal to the Laplace of f of t. Well, on the right side, I'm going to get that that is just capital F of s. On the left side, we know how to take the Laplace of a derivative. It will be s times the Laplace of g, which I will write as g of s, minus lowercase g of 0. Again, that is something that we proved before. We've decided now that g of 0 is equal to 0. So what this comes down to then is that s times g of s is going to be equal to f of s, which I want to write as g of s is equal to f of s divided by s. Again, what is g of s? Well, that is the Laplace transform of g of t. And what did we define g of t to be? If I scroll up here, we define g of t to be this function that is defined in terms of the integral. So if I just resubstitute that back, then what I get is that the Laplace transform of the integral from 0 up to t of f of tau d tau is equal to capital F of s divided by s. And that proves that result.